Hello everyone, this is Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today in this session, I am going to discuss about the concept of Border Gateway Protocol. Simply we can say that BGP, Border Gateway Protocol. So what is meant by Border Gateway Protocol? So BGP is the protocol that underlying the global routing system of the internet. So that means it provides an underlying the global routing system. It provides a global routing system of any organization, of any corporate offices, any offices or any organizations. So it provides complete routing of the internet. It provides complete routing of the internet. So it manages how packets get routed from network to network through the exchange of routing and reachability information among edge routers. So it provides a routing system for one network to another network, and it provides or it manages how packets get routed from one network to another network. Through what? Through exchange of routing. Through exchange of routing and reachability information among edge routers. So it provides a complete routing system and it manages how the packets get routed from one network to network, and it provides exchanging of the routing and reachability information among edge routers. So how it works actually? So here the BGP works as like each router maintains a routing table controlling how packets are directed. So each and every router contains a routing table. So it provides routing ID, source address, destination address, and how many packets are get transmitted. So each and every information is in the routing table. So it controls how packets are directed. And routing table information is generated by the BGP process on the router based on incoming information from other routers. And the information in the BGP routing information base. So BGP routing information base, that is nothing but BGP RIB. We can call it as BGP RIB. So it is generated by the BGP process on the router. That means it provides the information from other routers and information in the BGP routing information base. So it contains two informations. One is what? Other incoming router information as well as the router information base also. The routing information base. So those two information is having the routing table. So routing table information is generated by the BGP process on the router based on the incoming information from other routers and information in the BGP routing base. So it takes two types of information. One is other information from other routers, plus the router information base. So these two information having in the routing table. So which is data table stored on server on the BGP router. So the routing information base RIB contains what type of information? Information both from directly connected external peers as well as internal peers. That means the routers are connected to the external and the routers are connected to the internal. So those two information, they are saying that directly connected external peers as well as internal peers. And based on policies for what routes should be used and what information should be published. So what route should be used and what information should be published. So continuously updates the routing table as changes occur. So automatically whenever the packets get transmitted over the the router contains the information of other router as well as the routing information base of that router. So once the data gets transmitted over the routers, automatically the routing table having the changes occurred of all the updates. So continuously updates are going to be happened in the routing table as changes occur. So here the structure will see this is the peering ISP, that is nothing but internet service provider, and this is the exchange point, and this is the network service provider, and this is also network service provider. So here the border gateway protocol is run on internet service provider, router, and on private peerings. So this is internal peer and this is an external peer. So this is the external peer and these are all the internal peers that we are having. So here the BGP is developed with the help of internet service provider. So they provide the services to the particular network service provider. They provide internet service to the local network provider, and this local network provides gives an access to the local users, so that network is going to be distributed among all the routers. So this is the way the border gateway protocol works. So BGP is run on the internet protocol routers, internet service provider routers, and private peerings, and it is deployed on a minimal subset of core routers. So the customer is going to access the internet here. The customer is going to be accessed in the internet. So the internet service provider provides internet to the local network service provider, and the local network service providers provides internet to the local users, and these routers are going to be distributed the internet, and that internet is going to be accessed by the customer. So these all the works will be doing with the help of some external peers as well as internal peers. And what is BGP used for? So it offers network stability that guarantees on routers. And BGP makes routing decisions based on paths. So which path is better to provide a transmission, and which routing is better to forward the packets. And BGP uses client-server topology to communicate routing information with the client server. So they can able to provide some communication between the client server with the help of some communicate routing information. And some common BGP issues. So information exchange failures. Whenever the information is going to be transferred from source to destination or router to router, there may be a chance to exchange failures. That as information can be improperly formatted or contain incorrect data. So because of these two methods, the information exchange will be failure. So because of improperly formatted as well as contain incorrect data. And routers can run out of a memory shortage. Storage to be slow to respond to updates. So it provides some memory and it provides some storage that leads to get a response of slow. So it provides some updates. To get faster. And routers send error codes. And subcodes. Error codes as well as subcodes generated from the codes to communicate problems, including timeout problems, malformed requests, and processing problems. So routers can send some error codes and subcodes to communicate problems, including timeouts, malformed requests, as well as processing problems. So these are all some common BGP issues, common border gateway protocol issues. That and how we are going to provide the security, BGP security. So here the BGP is also vulnerable to attacks based on misinformation. Vulnerable to attacks based on misinformation. So by providing some misinformation, so there is a chance to attack on the routing system. There is a chance to attack on the routing system by attacker. And malicious actors can flood a router with bad packets in a denial of service attack. So malicious actors can send a flood of packets, bad packets they can able to send to denial of the service attacks. So send a denial of service attacks. So they can able to send different types of bad packets that leads to provide the denial of service attack. That leads to provide denial of service attacks. And what are the types of BGP attacks? So first one is what? Denial of service. So denial of service is nothing but it is an attacker can black hole portions of the internet either by creating false routes or by killing valid ones. By killing valid ones or by creating false routes. So that is a black hole portions. We can say it as denial of service is nothing but it is an attacker can black hole portions of the internet either by creating false routes or by killing valid ones. This caused much of the internet's routing tables to hold two ways to reach YouTube, one legitimate, the other bogus. So this caused much of the internet's routing tables to hold two ways to reach YouTube. One is legitimate, the other is bogus. That means they can able to access that much of internet's routing tables by using two ways. One is one legitimate way and the second one is bogus way. The second one is bogus way. So when the bogus route failed, it would seem reasonable for a router to try the other route. It would seem reasonable for a router to try another route. So if one route is failed, that is bogus route is failed, then it seems to be a change or it seems to be use another route. The problem is that today when confronted by one route that maps to a subset of other route, the most border routers are configured to choose sub-prefix and kill the prefix. Sub-prefix and kill the prefix regardless of the consequences of. So that means whenever the route get failed, then use another route or else use the prefix routers or else use the prefix routes. So that is nothing but we can have this denial of service attacks. An attacker may also kill valid routes by sending forged packets. So attacker can send some forged packets to destroy the routes. So that is nothing. Some sniffing, routing to endpoints in malicious networks, creation of route instabilities, and revelation of network topologies. So these are all some types of BGP attacks. And IP traceback techniques. So what is meant by traceback actually? So IP traceback is the process of identifying the actual source of the attack packets. So where the packets get attacked and what is the source of the packets get attacked. So the process of identifying the actual source of the attack packets. This has the benefits of holding attackers accountable for abusing the internet. So this has the benefit of holding attackers accountable for abusing the internet. The IP traceback methods are classified as reactive and proactive. So there are two types of traceback methods. One is a reactive method and second one is proactive method. So reactive identifies the traceback information after the attack has been occurred. So after the attack has been occurred, the traceback information after the attack has been occurred. So that means after the attack has been occurred, you are going to trace back the information. That is nothing but reactive. While coming to the proactive, identifies the traceback information when packets are traversed through the network. When packets are moving on, when packets are traversing on, at that moment the packets get traced back. traceback. So that is nothing but proactive mechanism. So one is the reactive mechanism and second one is proactive mechanism. So reactive mechanism works after packets get attacked. After packets get attacked. And the proactive identifies the traceback information when packets are moving on or when packets are traversing on throughout the network. So IP traceback technique is a DDoS technique. DDoS detection technique, that is nothing but distributed denial of service detection technique, which is used to trace the path of an IP packet to its origin. So one can find out the true identity of the attacker and can detect the path characteristics. So one is the DDoS detection technique, so which is used to trace the path of IP packet to its origin. So one can find out the true identity of the attacker and can detect the path characteristics also. So there are different types of IP traceback techniques out there. So one is the link testing, second one is packet marking, third one is ICMP traceback, and the fourth one is hybrid schemes. So these are all some different types of IP traceback techniques. So tracebacking nothing but finding the source of the packet that get affected by the attacker. Finding the source of the packet that get affected by the attacker. So where it actually affected and who is attracted to get the effect of that packet. So this is the actual routing process. So the host can use the route with the help of router 7 to router 4 to router 2 to router 1 and is the server. So this is the attack path actually. So attack path is nothing but attacker is going to be use the original path in his own control. Use this original path in his own control. So the user is going to use the server in this path, but attacker can able to attack on the middle of the routing. He can able to use the attacking path like A to R6, router 6 to router 3, router 3 to router 2, router 2 to router 1 to the server. So the traceback mechanism applies here. The traceback mechanism applied in two ways, reactive as well as proactive. So after reaching to the server, the reactive mechanism applies here. So the victim to the router 1, to the router 2, to the router 3, to the router 6, to the router, to the attacker. So like the way the tracebacking, that is nothing but identifying the source of the packet where we are receiving from. So that is the way you can use the path of traceback mechanism. So there are different types of IP traceback techniques. So regarding less reactive or proactive. So the first one is what? Link testing. That is nothing but reactive mechanism. So link testing can be used for determine the packet which carries the attacker's traffic. So the process starts from the router closest to the target. So link testing is performed before target. So that is nothing but the target before whatever the routers are there. The closest router is there between the target. The closest target to the router is going to be performed. The procedure is repeated for testing the upstream links to determine which one carries the traffic. So which router is closest to the target, from there we are going to perform the traceback mechanism, that is the link testing. So this is performed after attacking the packets only. And the second one is logging, that is nothing but proactive mechanism. So in packet logging based IP traceback, the packet may need to log on each router as it travels to reach the victim. So each and every packet is going to be logged in the router, each and every router. So at that moment what will happen? So each and every router maintains that packet, whoever entered into that router, whoever exited from that router. So that is nothing but keeping all the records. That is nothing but logging. And packet marking. Packet marking, that is nothing but a proactive mechanism. Proactive. So the main idea of packet marking based IP traceback is to mark the packets with its identification on each router which they possess. So from each and every router the packets get processed. Packets gets processed. So at that moment what we have to do? So we have to give the mark for each and every packet. We have to give the mark for each and every packet. So that the main idea of packet marking based IP traceback is to mark the packets with identification of the each and every router which they pass. And fourth one, ICMP based traceback. ICMP based traceback. So in ICMP traceback method, we use the iTrace method. We use iTrace method, and each router selects one packet per 20,000 packets. So here we are going to clubbing all the packets to positioning one packet, and then it also generates an ICMP message. It also generates some ICMP message. The ICMP message has the same destination IP address as the traced packet. The ICMP message also contains the IP header of the traced packet and the IP address of the incoming interface and the outgoing interface. So it contains each and every message contains IP address as the traced packet, as well as it contains IP header of the traced packet. So one is IP address of the traced packet as well as IP header of the traced packet, and also IP address of the incoming packet, incoming interface or outgoing interface of the current router. So when the victim receives the sufficient message, ICMP message, it can reconstruct the traversed path of packet. It can reconstruct the traverse of the packets. So these are all the different traceback techniques. Traceback techniques are happening in the real time. So once again we'll revise the topics which we discussed in this session. So the first one is border gateway protocol. So what is meant by border gateway protocol? So it is a mechanism of global routing system of the internet. It provides some certain routers, and each routers are going to be having some information like incoming information from other router as well as routing information of the one router. And it works by maintaining the routing table also. And this is the diagram for providing service with the help of border gateway protocol. So here the internet service provider uses for providing the network service, and the network service provider uses for providing internet to the local routers, and the routers are going to be distributed the internet, and the customer is going to be accessed the internet from the routers. And these are the external peers that are connected to the internet and internal peers that are connected to the internet. And so what are the issues that are related to the BGP? So that is one is information exchange failure, because of all the routers are having the information exchange. At that moment it gets failure. Because of that improperly formatted or containing incorrect data. So at that moment information exchange failures can be happen. So routers can run out of memory or out of storage. That gets very slow to respond updates. And that also sends some error codes or subcodes to communicate problems. That problems are related nothing but timeouts or malformed requests or processing problems. And BGP security. So it is also vulnerable to attacks based on misinformation, and malicious actors can send a set of bad packets to leads to the denial of service attacks. And these are all some types of BGP attacks. So denial of service attacks, sniffing attacks, routing to endpoints in malicious networks attacks, creation of route instabilities, and revelation of network topologies. So along with that, IP traceback techniques. So what is meant by traceback? That is a mechanism of the process of identifying the actual source of attack packets. So there are two types of traceback techniques. One is reactive mechanism and the second one is proactive. One is reactive mechanism and the second one is proactive mechanism. So reactive mechanism performs after packets gets attacked, after packets get attacked or after packets get traversed. But proactive mechanism during the packet gets traversed. So these are the two types of traceback mechanisms, reactive as well as proactive. On the basis of this reactive and proactive, the traceback techniques are divided into categories: link testing, packet marking, ICMP traceback, and hybrid schemes. So this is the mechanism of packets are going to be transmitted and packets get attacked, and how we are going to perform traceback mechanism of the attacked packets. So how we are going to perform traceback mechanism for the attacked packets. And these are the some common techniques. Link testing is one of the reactive mechanism, and logging is one of the proactive mechanism, and packet marking is one of the proactive mechanism, and ICMP based traceback mechanism is one of the proactive mechanism. So these are all the different types of different types of IP traceback techniques based on the reactive and the proactive mechanisms. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.